Hello everyone. By the end of this video, you should know how to find the domain of a function, whether it has a square root, a fraction, maybe both. We're going to go over examples that cover every aspect of finding the domain of a function. First, we're going to start off with f of x is equal to 2x plus 7. The domain of this function in interval notation will be from negative infinity to positive infinity. The same is true when we have another quadratic equation, 5x squared plus 3x minus 1. The domain for this quadratic equation is going to be from negative infinity to positive infinity. We're allowed to plug in any value for x here. If we had a polynomial equation, like f of x equals negative 6x to the third minus 4x squared minus 2x plus 7, the domain for this function will also be from negative infinity to positive infinity. The truth is that our domain will always be from negative infinity to positive infinity unless we have one of two restrictions. The first restriction is when we have a fraction. For example, if we have f of x equals 1 over x minus 2, the denominator cannot equal 0. So what we're going to do is get our denominator, in this case it's x minus 2, and set it equal to 0. This tells us what value of x gives us 0 in the denominator. If we add 2 on each side, we'll get that x equals 2, or a better way to think about it is that x cannot be equal to 2 because the denominator cannot be equal to 0. So when we're writing this in interval notation, we need to exclude 2, and this is where parentheses comes into play. We're going from negative infinity to the excluded number, and this is going to be in union with the excluded number to positive infinity. The parentheses tell us that we reach very close to 2, but we never actually get to 2, which justifies our answer that x cannot be equal to 2. Another example where we have a fraction is if we have 1 over x plus 3. We need to set the denominator equal to 0 to see what x cannot be equal to. If we subtract 3 on both sides, we're going to get that x cannot be equal to negative 3. And our domain will go from negative infinity to negative 3. And this will be in union with from negative 3 to positive infinity. The second case is when we have a square root. Number 2, square root. When we have a square root, whatever's inside of the square root must be greater than or equal to 0, which means that it cannot be a negative number. So let's say we had this f of x equals the square root of x minus 4. We need to set the inside of the square root greater than or equal to 0, which just means it cannot be negative. It can be positive or it can be 0. It cannot be negative. If we add 4 on each side, we're going to get that x is greater than or equal to positive 4. On a number line, this would be a solid dot at 4. And since x is greater than 4, we would shade to the right. In interval notation, this will go from 4 to positive infinity. Another example is if we have the square root of x plus 1. We have to set the inside of the square root to be greater than or equal to 0. We can subtract 1 on each side, and we'll have x is greater than or equal to negative 1. Since x is greater than or equal to negative 1, we're going to use a bracket, which we should have used here for 4, from negative 1 to infinity. Infinity will always have a parentheses. And if you have a number that's greater than or equal to, that's going to get a bracket because it is including negative 1. And this other example is including positive 4. So then now let's go over some more examples. Let's say we had f of x equals 1 over x squared plus 3x minus 10. The first step here is that we need to factor the denominator so we know what x cannot be equal to. We're going to have x here, x here. If you're having trouble with factoring this quadratic in the denominator, watch my video above on factoring quadratics. This quadratic factors out into x plus 5 and x minus 2. Now we can see what x cannot be equal to. We have x plus 5 cannot be equal to 0, and we have that x minus 2 cannot be equal to 0. If we subtract 5 here, we'll get that x cannot equal negative 5. And if we add 2 on the equation on the right, we'll find that x cannot equal 2. If we draw this on a number line, we'll have negative 5 here, we'll have positive 2 here. We'll have open circles in both. And the parts of the graph where our function has a domain is going to be highlighted in blue. And in interval notation, we go from negative infinity to negative 5. This is going to be in union with from negative 5 to 2, in union with from 2 to infinity. Our next example is going to be f of x equals 5x over x squared minus 3x minus 4. Our first step here is we have to factor the bottom so that we can identify what x cannot be equal to. X squared minus 3x minus 4 factors out into x minus 4 and x plus 1. We set each of these equal to 0, and we say that x minus 4 cannot equal 0, x plus 1 cannot equal 0. On the equation on the left, we can add 4 on both sides, and we'll get that x cannot equal negative 4, or positive 4. And here we can subtract 1 on each side, and we'll get that x cannot equal negative 1. Our domain will go from negative infinity to negative 1. This is going to be in union with from negative 1 to 4. In union with from 4 to infinity. Next we have f of x equals the square root of 2x plus 3. What we need to do here is set what's inside of the square root to be greater than or equal to 0, which means that it can not be negative. We're looking for what value of x produces a non-negative number inside of the square root. The first step is to subtract 3 on both sides. We'll have that 2x is greater than or equal to negative 3. And then we're going to divide each side by 2. We'll get that x is greater than or equal to negative 3 over 2. If we were to draw this on a number line, we would have a closed circle at negative 3 over 2. And we would shade to the right since x is going to be greater than this value. The way we write this in interval notation, the leftmost point is going to be in a bracket, and that's going to be negative 3 over 2. The bracket corresponds to the solid dot, and this is going to go all the way to infinity because the blue line goes all the way to the right since x is greater than this number. Next we have f of x equals 2 minus the square root of 3x minus 4. Similar to the last question, what we need to do here is set the inside of the square root to be greater than or equal to 0. This 2 minus part, the fact that the square root is negative on the outside and there's a 2 in front subtracting from it, doesn't change the process of finding our domain. We identified that there is a square root, so we need to find or set what's inside of the square root greater than or equal to 0. Our first step here is going to be to add 4 to both sides, and we'll get that 3x is greater than or equal to positive 4. And then we're going to divide each side by 3. And we'll get that x is greater than or equal to 4 over 3. When we draw this on a number line, we write positive 4 over 3. And since x is greater than 4 over 3, and it's greater than or equal to, we can draw a solid dot. And since it's greater than, we're going to shade to the right. In interval notation, we're starting off with a bracket at 4 over 3, and we're going all the way to infinity. Next we have f of x equals 2 over the square root of x minus 1. Now this case is a little bit different because it has both a square root and a fraction in play. The fraction makes it so that the denominator cannot equal 0. So we have that x minus 1 cannot equal 0. And the square root part tells us that x minus 1 needs to be greater than or equal to 0. So looking at this inequality on the right, x minus 1 is greater than or equal to 0. Well, we know that x cannot equal 0. So we need to modify this inequality on the right to get that x minus 1 must be strictly greater than 0. It cannot equal 0 because it's in the denominator. It cannot be negative because it's inside of a square root. So when we have a fraction and the square root in the denominator, it's going to be what's inside of the fraction strictly greater than 0. To get x by itself, we're going to add 1 on each side. And we'll get that x is greater than positive 1. On a number line, we're going to write 1. It's going to be an open circle since it's strictly greater than. And since x is greater than 1, we're going to shade to the right. In the examples previously, whenever we had a square root, we would write a bracket, and that was because we had a solid dot in our graph. In this case, we do not have a solid dot, so we're going to have a parenthesis. We can get very close to 1, but we cannot touch 1. It cannot be 1. So we're going to go from 1 to positive infinity. Our last question for this video is going to be f of x equals 3x over x squared minus 5x plus 6. Sorry, minus 6. And the entire denominator is going to be inside of a square root. So our goal is to set what's inside of the square root to be greater than or equal to 0. And the fact that it's in the denominator tells us that it cannot be equal to 0. So we're going to erase the fact that it cannot be equal to 0. So we'll have x squared minus 5x minus 6 is strictly greater than 0. We can factor this out into two binomials to be greater than 0. And that's going to be x minus 6 and x plus 1. We're going to set each of these to be greater than 0. And we'll get that x is greater than 6 and x is greater than negative 1. If we draw this on a number line, we have negative 1 here, we'll have 6 here. They're both going to be open circles. And then we're going to have a line going. Since x is greater than negative 1, we're going to draw it this way. And since x is greater than 6, we also have to draw it here. So since negative 1 is not involved in the second or the first inequality, that means that the only solution will be when x is greater than 6, because the two conditions need to overlap together. And for example, negative or 0, positive 3, positive 4, none of these are greater than 6. They're greater than 1 and they meet one of the criterias, but they don't meet both. So the equation or interval notation of the domain for this function is going to be from 6 to infinity. If you learned something new in this video and you enjoyed, please make sure to like the video and subscribe to the channel for more math content like this. I'll see you in the next one.